orthogonal trajectory is that you have the original function and the original function, that's the basic idea. And then what class of functions would it be that would be orthogonal, which is just a fancy way to say perpendicular. So would it be a curve that looks like this, so that when they cross, if you looked at their tangent lines, this one's tangent line would look like that, compared to this one's tangent line, and that they cross at 90 degrees. Well, for this one's tangent line, we would need the derivative. And for this one's tangent line, let's say this function is going to be g function. So the red one is g, and the black one is f. So then for this red one, the derivative would be, well, if these two lines are perpendicular, then the slopes have to be negative reciprocals. Since derivatives give us slopes of tangent lines, then these two need to be negative reciprocals of each other. That means that this one has to be negative the reciprocal of the other one. Now to go backwards and find out what g is, we just need to integrate. So integrate negative 1 over 3x squared. So I could factor out the 3, and negative 1 over x squared, that's the derivative of 1 over x. If you don't see it that way, what you could do is factor out the negative 1/3 constant. For this, you could rewrite it as x to the negative 2. And then when you integrate, you add 1, which will be negative 1, and then divide by that number. Now that we're done integrating, we need a plus c. So it looks like the negatives will cancel, and don't leave negative exponents, so this is going to be 1 over 3x plus a constant. So this function right here, when you look at their tangent lines, they should be perpendicular. Let's see. So if you look at what we got, which is 1 divided by 3x, and then plus c would just move it to different places. So let's see if we can see what's going on with just these two. So there's two places where they intersect. I do need to zoom in. So if you look at right here where they cross, so I need to zoom in even more. If you zoom in enough, they basically do look like straight lines. And they should look perpendicular. I don't know, I'm a little skeptical. Oh, there's a problem. The calculator is a rectangle. The screen of the calculator is a rectangle, so it's actually taking square information and it's stretching it like this, so they don't quite look perpendicular. But the math tells me that they are, so I'm going to believe that.